Welcome to the Bare Metal Cyber CRIC Prepcast. This series helps you prepare for the exam with focused explanations and practical context. Collaborating with control owners during the control selection and design process is essential for translating risk treatment goals into functional, sustainable actions. Risk owners may understand the business impact of risk, but it is control owners who possess the operational and technical insight necessary to execute control activities effectively. C-risk professionals serve as the bridge between these roles, ensuring that risk-reducing measures are not only strategically aligned, but also operationally feasible. Control design failures often stem from a lack of this collaboration. Controls may look appropriate on paper, but if they are difficult to deploy, maintain, or scale, they fail to achieve their intended outcome. On the C-risk exam, many scenarios involving failed or rejected controls can be traced back to poor coordination in the design phase. Effective risk mitigation requires both strategic intent and operational realism, and C-risk professionals facilitate the conversation that makes both possible. The control owner is responsible for the end-to-end life cycle of a control. This includes implementation, daily operation, performance monitoring, and ongoing maintenance. Depending on the control type and the part of the organization it supports, the control owner may be from IT, cybersecurity, finance, HR, or operations. Regardless of their functional area, control owners must understand what the control is intended to accomplish and how it ties back to risk scenarios. C-risk professionals must communicate both the business reason for the control and the technical expectations for its deployment. This often requires translating abstract risk concepts into operational language that resonates with the control owner's daily responsibilities. On the exam, when a control fails due to misunderstanding or confusion about its purpose, the root issue often lies in miscommunication between C-risk professionals and the control owner. Strong answers demonstrate clarity of purpose and shared understanding. Selecting the appropriate type of control depends on the nature of the risk, the criticality of the affected assets, and the operational environment. C-risk professionals collaborate with control owners to evaluate whether the situation calls for preventive, detective, or corrective controls. Preventive controls aim to stop incidents from occurring in the first place. These include access controls, encryption mechanisms, and segregation of duties. Detective controls are used to identify that a risk event has occurred and include system logging, monitoring tools, and anomaly detection alerts. Corrective controls help return the environment to a safe state after an event and may include automated recovery procedures, backups, or manual workarounds. Controls can also be categorized by layer: technical, e.g. endpoint security; administrative, e.g. policy enforcement; or physical, e.g. building access restrictions. The most effective environments use layered defenses that are matched to both threat type and impact level. On the exam, questions asking which control best addresses a risk are best answered by mapping the control type directly to the threat and vulnerability characteristics. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Once a control type is selected, the design phase must evaluate each option for fit and feasibility. This includes analyzing whether the control is likely to reduce the target risk, how much it will cost, what resources will be required, how long it will take to implement, and how well it will integrate with existing systems and workflows. Some technically effective controls may be too expensive or too slow to deploy in time. Others may interfere with employee productivity, leading to pushback or workarounds that undermine their purpose. C-risk professionals guide this evaluation by considering control strength in the context of organizational appetite, urgency, and operational readiness. On the exam, if a control leads to unintended user resistance or fails to integrate with systems, the correct answer often involves poor usability or design misalignment. The best answers reflect control maturity, feasibility, and balance between security and business function. Designing the control requires ensuring that it meets the risk treatment objectives without over-engineering or redundancy. Controls must be mapped directly to the specific threat, vulnerability, and asset involved in the risk scenario. C-risk professionals ensure that every control implemented has a clear rationale for why it was chosen, how it mitigates risk, and what dependencies or assumptions support it. For example, if a control is intended to restrict privileged access, its parameters must include who qualifies as a privileged user, how access is granted and revoked, and how logging and alerts will be configured. Controls should also be reviewed for overlap with existing safeguards. Adding multiple overlapping controls may result in inefficiency or create a false sense of security. On the exam, when design logic is tested, vague or generic answers are usually incorrect. The best choices involve clearly mapped relationships between the control, the risk scenario, and the operational environment. Once design is finalized, implementation responsibility must be clearly assigned. C-risk professionals help define who will lead the setup and deployment of the control, who will test and validate it, and who will be responsible for its long-term maintenance. In some cases, multiple teams are involved. IT may deploy the system, security may configure the settings, and operations may monitor daily performance. In such cases, using a RACI matrix defining who is responsible, accountable, consulted, and informed helps clarify responsibilities and reduce handoff errors. Governance teams must also be able to trace accountability through documentation and periodic reviews. On the exam, when a control is deployed but never maintained or tested, it often signals a gap in role assignment. The best exam answers assign control roles in a way that reflects functional authority and operational continuity. Control design must also comply with recognized standards and frameworks. This ensures that controls meet both internal governance expectations and external regulatory requirements. C-risk professionals reference standards such as ISO 2731, NIST SP 853, the CIS controls, and COBIT to guide design completeness and audit readiness. These frameworks help ensure that controls are thorough, documented, and suitable for the intended environment. They also help facilitate control testing, audit support, and certification processes. If a control fails an audit, even if it is technically functioning, the issue may be due to poor documentation or failure to meet framework requirements. On the exam, if a scenario involves a control that operates but fails an external review, the correct answer often involves standards misalignment or poor documentation. Strong answers align control selection and design with both risk objectives and compliance expectations. Before deployment, the control design must be tested. This helps confirm that it addresses the intended risk, that it cannot be easily bypassed, and that it performs consistently across environments. Testing might involve simulation, peer review, or tabletop exercises. For example, a new access control process might be tested by attempting unauthorized access and verifying that alerts are triggered. Dependency testing also helps ensure that related controls or systems are in place and working correctly. An alerting system won't work if the logging component it depends on fails. C-risk professionals help define test criteria, expected outcomes, and success metrics. On the exam, if a control fails after implementation, the clue may lie in a missing or rushed testing phase. The correct response is often to revisit the design and perform structured testing before rollout. Documenting control design decisions supports governance, knowledge transfer, and continuous improvement. C-risk professionals ensure that each control is logged in the control library or GRC platform, along with its design objective, implementation plan, owner, testing method, and dependencies. This documentation allows others to understand why the control exists, how it should operate, and how its effectiveness will be monitored. It also supports audits, control reviews, and onboarding of new team members. Proper documentation is often the difference between a control that is sustained over time and one that fails during transition or organizational change. On the exam, when documentation is missing and controls cannot be validated, the right answer will involve creating or updating the control design record. The strongest choices reflect disciplined documentation practices aligned with governance maturity. T-risk exam questions on control selection and design often test the ability to match the right control to the right scenario. You may be asked which control best mitigates a specific risk, and the correct answer will depend on understanding the threat, the vulnerability, and the desired outcome. Other questions may ask why a control failed, and the root cause may be poor design, misalignment with risk, or insufficient testing. You may also be asked who should be consulted during design, and the answer will usually involve both the risk owner and the control owner, with facilitation by the C-risk professional. In some cases, you'll be asked what to do before implementation, and the answer will include testing, documentation, and validation. The best responses reflect cooperation, technical feasibility, business relevance, and controlled design maturity. Thanks for joining us for this episode of the Bare Metal Cyber CRS Prepcast. For more episodes, tools, and study support, visit us at baremetalcyber.com